Remember that a Lewis dot structure is a way of diagramming the valence electrons of an atom, and that an ion is an atom or molecule that has gained or lost electrons and has a positive or negative charge. Now here's some new vocabulary. A polyatomic ion is an ion made of two or more atoms that has a positive or negative charge. An example of a polyatomic ion is ammonium ion, NH4+. Notice it fits the definition by being made of two or more atoms and having a positive charge. The charge on a polyatomic ion comes from having either too many electrons for a negative charge or too few electrons for a positive charge. The charge itself is spread out over the entire ion, not located on any of the particular atoms. Okay, hang with me here. Let's look at NH4+ as its separate pieces. N, nitrogen, has 5 valence electrons. Each hydrogen, H, has 1 valence electron. So 4 hydrogens have 4 valence electrons. The 5 nitrogen electrons and 4 hydrogen electrons add up to 9. 5 plus 4 times 1 equals 9. When the 1 nitrogen and 4 hydrogen combine to form NH4+, they lose one of their 9 electrons so they can meet the octet rule. So instead of being neutral, it now has a +1 charge. The formula for NH4+ is sometimes written like this, to show that the whole group of atoms has a charge, not just the hydrogen. This Lewis dot structure looks like this. Let's look at another example. Sulfate ion, SO4, -2. Sulfur, S, has 6 valence electrons. Oxygen, O, has 6 valence electrons. The total is 6 times 4 plus 6 equals 30 electrons. Now write the Lewis dot structure and count the electrons. You can see that they combine to make a polyatomic ion. They have to have 32 electrons so that the octet rule is followed. 6 electrons around each O, because they are each sharing 2 electrons with the sulfur, and 8 around the S, for a total of 6 times 4 plus 8 equals 32. So you've added 2 negatively charged electrons to make this ion work, so the charge on it is -2. See how that works? Try one more. Phosphate ion, PO4, -3. Phosphorus, P, has 5 valence electrons. Oxygen, O, has 6 valence electrons. This total is 4 times 6 plus 5 equals 29. Make the Lewis dot structure. In order for the octet rule to be met, the total is 4 times 6 plus 8 equals 32. So you had to add 3 electrons to this ion, and it has a -3 charge. A resonance structure is when a compound has 2 or more possible configurations with the same geometry, but different arrangements of electrons. All it means is that a compound can be written in different ways. Electrons aren't static objects. Although we draw our diagrams as though they stay in one spot, electrons travel around. Take ozone for instance, O3. The Lewis dot structure shows that it has a double bond between 2 of the oxygens, but this bond can be either O double bond O single bond O, or O single bond O double bond O. To show that the 2 structures are resonance structures, put a double-headed arrow in between the 2 to show that it can be either one. Another example is NO3. Although you may think that in real life compounds are alternating between or among the resonance structures, they're not. It is hard to represent accurately a real-life situation by a 2D drawing. So in real life, instead of there being a double bond between the nitrogen and one of the oxygens, there may be kind of a 1 1/3 bond between all the oxygens and the nitrogen. Some compounds have multiple resonance structures, and the compound doesn't spend its time equally in all of them. A compound will spend most of its time in the structure that is best for it. A polyatomic ion is an ion made of 2 or more atoms that has a positive or negative charge. You determine the charge on a polyatomic ion by figuring out how many total valence electrons are normally present in the different atoms making up the polyatomic ion. Then figure out how many electrons will be needed to meet the octet rule. Then determining how many electrons you had to add or subtract to meet the rule. And this is the charge of the polyatomic ion. Polyatomic ion formulas are often written in brackets to show that the charge applies to the whole compound, not just one atom in it, like this, NH4+. A resonance structure is when a compound has two or more possible configurations with the same geometry but different arrangements of electrons, which means that sometimes Lewis dot diagrams can be written in more than one way for the same compound.